Hey guys, so for our project we decided to build a log splitter. Before we get into the details of how we built it, I wanted to talk about the actual welding method that was used throughout the project. Most welders you would see in industry would be large 220 or 440 volt welders that can weld material that's a few inches thick and possibly even thicker than that. The welder we used is a small MIG welder that's designed to run off of your typical household 120 volt outlets. Some of the material we used in the project really pushed the small welder we were using to its limits. However, it did work good enough to complete our project. So, like we talked about in class, MIG welders are wire-fed welders that create joints by melting the metal in a localized area, adding filler material, and then allowing the joint to cool. Most MIG welders will use some kind of shielding gas like argon to prevent oxidation in the weld, but these small welders can use a wire that has a flux-filled core. This core melts during the welding process and releases the shielding gas, so the same effect is achieved. There are several small points I can make about MIG welding, or welding in general, but for the sake of time, the last point I want to make before I start talking about the build is that if there is one thing our group learned during the project, it's that welding is a skill that takes a lot of practice and time to get right. If you ever do take on a welding project, remember that there are three pretty important concepts. You need to prep the material extremely well. Then while you're welding, maintain a constant speed and path. And then you just need to have a lot of patience. So with that said, let's start talking about the build. At the core of our project was an 8-ton pneumatically actuated hydraulic cylinder. It operates like a common bottle jack you would use to raise a car, but just on a larger scale. The compressed air feeds into a small air pump that provides the hydraulic pressure to raise the cylinder. We are worried that 8 tons of force may not be enough since most commercial log splitters come with around a 22-ton ram, but it turned out to work just fine. So moving on, most of the material we used was acquired from friends or family that had scrap laying around. The only thing our group purchased was the threaded rod used for the pins in the cylinder and the axle, and then we bought the cylinder itself. The first thing we did was take measurements of the cylinder in its retracted position and extended position, added in the length of the wedge and a couple other parts of the splitter to figure out how long the I-beam needed to be cut to. This didn't need to be an exact measurement, it was just easier to cut the beam before adding the rest of the pieces on, and we didn't want to have a lot of extra length on the beam. We cut the beam using a bandsaw until the blade broke, and then we finished the cutout with an angle grinder with a cutoff wheel on it. We then moved on to building the wedge. The wedge was two half-inch thick pieces of steel that were welded together and then sharpened to a point. After that, we decided to use a piece of 1-inch thick steel to raise the wedge up. We also cut a point onto this piece so that it would act as a secondary wedge and help push the split pieces off the side and away from the back plate. Once all these pieces were cut, we welded the back plate on, then the riser, and then the wedge. It was a little challenging getting everything welded up, but this was one of the easier parts of the project. After all of that was welded up, we started to build the skid. This is the piece that attaches to the end of the cylinder and forces the log into the wedge to split it. This was by far the most challenging part of the build. The skid has to resist all the force that is exerted on it, and it also has to act as a guide for the piston so that it can't rise up or move left or right. We used a thick plate for the part of the skid that would contact the log, and then used angle iron and flat stock to create the guides that went under the I-beam flange and locked the skid so that it could only move forwards and backwards. We then built the axle using a piece of angle iron, small sections of threaded rod, and two wheel and hub assemblies off of an old lawnmower. The angle iron was cut to length, the threaded rod was welded on to act as a spacer to keep the tires away from the angle iron, and the hubs were welded onto the threaded rod to mount the wheels. It was a pretty simple design, but turned out to work really well. We were a little worried it may be too low to the ground, but decided that you wouldn't want to have to pick the logs up any further than you had to get them onto the splitter. It actually turned out to be the perfect trade-off between ground clearance for towing and lifting height for the log. We welded the axle onto the beam and then moved on to welding the end plate for the cylinder. We used another piece of thick plate for this and cut a small square out that allowed the cylinder mounting holes to pass through the plate and let the flat base of the press directly onto the plate. We then used angle iron and more threaded rod to mount the cylinder. The way the cylinder is mounted, all of the force goes into the thick plate when the ram is extending and being retracted. This works out great for keeping the forces off of the mounting rod. Once the backing plate was mounted, we then made a tongue that would allow for the splitter to be hooked up to an ATV or a lawnmower. This was made out of square tubing, and a bolt was used to pin the tongue into the receiver on the lawnmower. The low height of the beam made it easy to directly weld the tongue under the beam without having to put any bends in the tongue. Once that was done, the only thing left to do was test it, and I'll let you see how that went for yourself. One thing I do want to note is that the cylinder has no way to retract itself right now, but in the future we plan to add springs between the end plate and the skid that will pull the cylinder back without having to manually do it. Thanks for watching.